Hey, welcome to the next lecture about the sample preparation. Sample preparation is actually one of the first parts that analytical chemists um, come across during the process of analysis. And actually, it's quite often still a bit overlooked when the whole flow of the analytical procedure is being described. For example, in the uncertainty evaluation, very often it turns out in the end that the sample preparation is somewhat too optimistically described. So in this lecture, we try to look a bit into the sample preparation. We will look into different techniques and also the challenges that are faced. But before we actually dig into the techniques as such, a few years ago, liquid chromatography, gas chromatography, so LCGC, which is a very popular magazine, or in among analytical chemists, especially chromatographers, but also, for example, mass spectrometrists, carried out a kind of a survey among their readers. And among other questions, they also asked about sample preparation. And one of the questions that they asked was what types of samples are being analyzed by the readers then of LCGC. And among LCGC readers, the most popular types of samples were pharmaceutical samples and environmental samples. And though this is more chromatography, mass spectrometry related journal, we could say that a big bunch of the samples that analytical chemists come across belong either to one of these two main categories. Another very prominent category, but by far less prominent for these readers, were the agriculture and food samples. So into this category belong all types of food quality control, as well as, for example, custom control of imported foods and similar things. Also, organic chemicals, which is more industrial quality control questions, were emphasized, as well as polymer or biotechnology, medical samples, forensics were actually surprisingly prominent. Even a few percentages among the responders came across forensic samples, as well as other smaller categories. But the most prominent were environmental and pharmaceutical samples. So environmental belong actually a very wide, different range of samples, starting from air samples through water samples, down to soil and waste samples, for example. Into pharmaceutical sample category belong also very different samples, or can belong very different samples. It is not absolutely sure if into this category some of the responders also indicated, for example, medical samples such as drug studies from blood samples, but definitely here belong all kinds of pharmaceutical quality control and production samples. So all this kind of things could belong here. And of course, this kind of information is very important when we start looking at what kind of sample preparations are important in analytical chemistry, because the samples are very much determining what kind of sample preparations we can use. And this means both what is the form of the sample, is it a liquid, is it a solid, is it a gas, as well as what types of analytes they are. And also, what is the speed of the sample preparation that needs to be applied? Are there hundreds of samples that need to be analyzed within an hour, or are they more a few samples where you can consume more time on preparing the samples? Another important question that they asked were how many samples are the analysts actually facing, and um, and this was asked per instrument per week. So kind of how many samples per week would one person or one instrument need to analyze? And this could be told now to be a bit outdated because the last information comes from 2001. So probably the higher numbers have increased a lot, the percentages. But what we could see here is that each of these percentages here indicates how large percentage of the persons who responded to this questionnaire had number of samples in this range. So actually in 2001, still a fairly large number of labs had somewhere between less than 20 to 50 samples. So majority of the labs belong to this category. Actually also quite many labs, so 22% approximately, had between 50 and 100 samples. So when we think about 100 samples and the fact that the work week is 5 days for most labs, then this means that during one day, 20 samples need to be prepared. And this could give you kind of a estimation how fast the sample preparation needs to be, as well as how fast the analysis needs to be to actually be able to analyze all the samples with this time. And of course, it's very likely that in most laboratories this is per instrument per week, but actually there are more instruments than analysts, which means that per person there will be more samples. And I'm absolutely sure that these percentages have actually increased in over the last 20 years then. And a slightly later question here also asked about the time that the labs are consuming on different steps in the liquid chromatography analysis, because this was still conducted by LCG's journal. So, and interestingly, it turned out that in the sample preparation, data analysis, collection of the samples and analysis time, the sample preparation by far consumed most time. This, of course, depends strongly on the type of analysis, but the fact that sample processing took most time for 61% of the labs, this is very much indicative how labor intensive sample preparation is. And automatization of the sample preparation definitely still is an ongoing question in analytical chemistry. This is by far not solved yet. And additionally, due to actually the same fact that sample preparation is so time consuming, also labor intensive, sample preparation is also prone to errors. So the responders indicated, 30% of the responders indicated sample processing as a very important source of error. And this is actually also logical because sample preparation is one of the least automated processes that analytical chemists do, which means that there are a lot of things that could go wrong. Again, also, the sample processing is also very much dependent on the samples. And if the sample to sample variation is large, then we can also expect larger errors here. So this means that sample processing is important, both from the time perspective, as well as from the analysis accuracy perspective. So considering everything that is associated with sample preparation is essential. So why do we prepare sample, or rather, how should we prepare the sample? So of course, we want to prepare the sample so that it would be suitable for the analysis. But what does that mean? That means that the samples should be representative. That means that the concentration of the prepared sample that we start now measuring with our analytical techniques should actually represent the analyte concentration in the real samples. Also, the sample should be homogeneous and the preparation should be reproducible. That means that the reproducibility that incorporates also sample preparation should be as good as possible. Of course, we want to get rid of or eliminate the effect of any interfering compounds. So, for example, if we know that there are interferences, we want to get rid of them. And this now again very much depends on the objective, on the analyte, and on the sample, how likely the interferences are and which kind of interferences we might have there. If also the solvent, what we are using to prepare our samples in, mostly we operate with the solutions in the measurements, is very important. So for example, if we deal with chromatography, then the solvent should not interfere with our columns anyhow. For example, we should not prepare our samples in water if we want to inject the samples to gas chromatography. Also, it's very important in mass spectrometry, not all solvents are compatible with all ionization sources. And in low concentration samples, it's very important to concentrate the samples sufficiently during the sample preparation so that we would achieve the desired limits of detection. And for the same purpose, derivatization may be needed. This especially when we are doing some UV or fluorescence measurements, or we do chromatography measurements with UV or with fluorescence. So then derivatization is important, and concentrating is very important in very many cases. In some cases, also dilution can be very important. This is when we are dealing with very concentrated samples. We would like to get our analyte concentration to the linear range. So this is especially important, for example, if we deal with the analysis of the main components, or for example, with the analysis of assays in case of pharmaceutical quality control, for example. And in the next part, we are going to look through the analysis of gases, liquids, and solids, because the methods actually strongly depend on what is the physical form of the sample that we are having in our analysis.